This video will continue to discuss linear relationships. Specifically, we're going to focus on how you can start writing linear equations and understanding linear equations. Remember that a linear relationship is any relationship between two variables that forms a straight line when graphed on a coordinate plane. There are four main ways to represent a linear relationship. So far we've been working a lot with graphs and tables. This video will focus on how we can take what we know about linear relationships from graphs and tables and create an equation. There's two key things we need to know to write a linear equation. Those are the initial value, the y-intercept, and they are the slope, what we could also call the rate of change. We've worked on finding this information for both graphs and tables. You should recall that the y-intercept is the value for y when x equals 0. That's also going to be the point on the y-axis where the line crosses it or intersects with it. The slope is your unit rate of change, and it's going to tell us how much the value for y will change by each time x gets increased by 1. Once we know these two values for our linear relationship, we can write an equation that always takes the same form, y equals mx plus b, and we're going to look at that more in our example today. For our example, linear relationship B, we see this blue line and a bunch of work done already to determine both the slope and the initial value. Recall the initial value is the y-intercept. It tells us where the blue line crosses with the y-axis, and the blue line hits the y-axis at 0 and -3. That tells us when x is equal to 0, the beginning of this relationship, y will have an initial value of -3. We also see slope is measured out using two different sets of data points. The first set in red goes from the red dot to green dot. We see y increases by 4 units as the x increases by 2 units. That's a rise over run of 4 over 2. That would be the same ratio we see from the purple to the maroon dot. We would rise up by 2 units for the y value, and the x value would run 1 place or 1 unit to the right. Would write that as a ratio 2 over 1. These are equivalent ratios. They both simplify to make 2. That's our slope. It tells us the unit rate of change. In this case, y is increasing by 2 units every single time x increases by 1 unit. Taking this understanding and trying to write an equation, we should now understand that relationship B has an initial value of -3 at the beginning, or when x is equal to 0. Every time we increase the x by 1 unit, our y value is going to start increasing by 2 units. So our value for y is always equal to that initial -3 plus 2 units for every x. We could write this as an equation. Y is equal to the initial -3 plus 2 for every single x. As we'll see, every linear relationship can take an equation in what we call slope-intercept form, where y is equal to mx, that's our rate of change, multiplied by however many x's we have, plus our initial value. In this case, y equals 2x plus -3. If your equation is correct, it should work for any data point on the graph or in the table. We see here the green data point when x is 2 and y is 1. If we plug it into this equation, replace the y with 1, replace the x with 2, 2 times 2 is 4. 4 minus 3 leaves us with 1 for y. It works in this equation. We see another example from the line, 5 for x and 7 for y. If we substitute 7 in for y, 5 in for x, 2 times 5 is 10. 10 minus 3 leaves us with 7. It works in that equation as well. We can be confident that this equation, y equals 2x plus a -3, is the equation to match this graph.